Hello everyone, welcome back to the Control System Engineering lecture. Today in this lecture we are going to study about the polar plot. The polar plot is one of the method in the frequency and domain analysis which provide you the stability of your system. So let's start with the polar plot. We have studied about the different kind of coordinate system. One is a graph Cartesian coordinate system and the polar coordinate system. In the polar coordinates, we have different radius of circle and there are different angle are there. So these are look like this. If I represent the one point in a coordinate, then I can write in this manner m equals to x plus jy, where y is an imaginary axis. Similarly, the equivalent value of the point in the polar coordinate can be represented by where r is the magnitude represented by x square plus y square and theta is the phase of the system represented by tan inverse of y upon x. So this is the relation between this coordinate system and this coordinate system. So the polar plot is actually designed the behavior between the magnitude and the phase of a system. You can draw a polar plot on a polar plot, a regular polar plot. However, we are going to use the real imaginary axis plot in this case. But the polar plot is called the polar plot because it actually plots the magnitude and the phase with the change in the frequency omega from 0 to infinite. So let's start with the polar plot. So this is the polar plot. Let me start with the system. Let's say GS equals to some system like 1 divided by, let me take again 1 in this case, S plus P1, S plus P2 and so on. How much pole we have? Or let also take a type of a system, that S to the power n is here. So how to draw a polar plot? The first step for designing a polar plot, represent the transfer function in frequency domain j omega form, which is j omega equals to 1 upon j omega to the power n s j omega plus 1 p1 j omega plus p2 and so on. This is the first step. Second step, write down the formula of the magnitude and the phase of a system. The magnitude of system will be mod of j omega equals to 1 divided by omega to the power n square root of omega square plus p1 square root of omega square plus the angle of the system j omega is equals to 90 multiplied by n because it is an pole at origin, so it will contribute by 90-degree angle multiplied by number of pole it has minus tan inverse omega y p1 minus tan inverse omega y p2. So this is the second step. Third step for design a polar plot is find out the value of phase and magnitude of system at omega equals to 0 and omega equals to infinite. So we find g omega at omega equals to 0. What is the value? Find out g omega at omega equals to infinite. Similarly, the angle of j omega at omega equals to 0, angle of j omega at omega equals to infinite. So what are these values? The next fourth step is convert the given equation g j omega in the form of a plus jb. So how we do it? If g j omega is equals to 1 divided by j omega to the power n j omega plus p1 and j omega plus p2 multiplied by conjugates of these values, and we will have the expression in the form of a plus jb. Okay. Step 5 is find the frequency at which the value of real part and imaginary part is equals to 0. Means it will give you the point on the real axis and the imaginary axis. And the next step is sketch the polar plot. So these are the steps for drawing the polar plot. Let's take a few examples to better understanding of how to sketch a polar plot. Gs equals to 1 upon s to the power n. Let's say we have nth type of system. So how to sketch a polar plot for this system? First we simply plot an axis where we have this is your real part and this is your imaginary part. Define that. Also note that if you are measuring the angle in this direction, then start with a 0, 90, 180 and 270 degree. If you are measuring angle in this direction, then it will be the minus 90, minus 180 and minus 270 degree. So always remember. So how to sketch a polar plot? The first step, to represent your transfer function in the form of frequency j omega equals to 1 upon j omega to the power n. Okay. Find out the value of magnitude. Magnitude of system will be power n. Angle of the system will be minus n times 90 degree. Okay, so while we are sketching a polar plot, it is clear that when we substitute the value of omega equals to 0, the magnitude, this is the second shown, magnitude g j omega will equals to infinite, and at omega equals to infinite, the magnitude of g j omega is equals to 0. Similarly, the angle at g j omega at omega equals to 0, it will be minus 90 degree. So let's take a value of n equals to 1, and since n equals to 1, the angle is a minus 90 degree, so this is your minus 90 degree axis, and we can see that the at angle omega equals to 0, at frequency omega equals to 0, the magnitude is infinite. So at omega equals to 0, the magnitude is somewhere on infinite axis, and when we increase the value of omega, the magnitude will start decreasing, and it will converge to the point here, because at omega equals to infinity, this is your omega equals to infinity, the magnitude is equals to 0. So the polar plot for the type 1 system, when n equals to 1, it is 1 upon s. This is your polar plot of the system. Similarly, if you substitute the value of n equals to 2 for a type 2 system, the magnitude will start from omega equals to 0, which is infinite, and will come back to this position. Angle is minus 180 degrees somewhere here. So it will start coming from this direction and will converge to that position here, like this. omega equals to 0, somewhere at infinity, at omega equals to infinite is here. Similarly, when n equals to 3, the angle will be 270 degree. So we will have a different kind of plot. So this is your plot for this is for n equals to 2. This is for n equals to 3, and this is your 1 upon s cube. Okay. Similarly, when n equals to 4, we will have this graph. This is your 1 upon s to the power 4 at n equals to 4. This is your omega equals to 0, and this is your omega equals to infinite. So this is how we draw a polar plot. This is your different type of system, and different type of system, how they exist in the different quadrant. If you have a type 1 system, it will somewhere exist somewhere at this position at the minus 90 degree. If we have type 2 system, it will exist after the minus 180 degree, because the minimum angle is introduced by the type 2 system is minus 180 degree. Minimum angle introduced by the type 3 system is minus 270 degrees. So all type 3 system have all plot after this position. Minimum angle produced by the type 4 system is again 360 degrees. So we will have after this position. So this is a basic example. Let me take another example. Example 2, we have a generalized transfer function gs equals to 1 upon tau s plus 1. Okay, so we have tau s plus 1, the transfer function. So we have to sketch a polar plot. So we will start in the step by step. First step, to represent the transfer function g j omega equals to 1 upon tau j omega plus 1. Step 2, find out the magnitude. G j omega equals to 1 upon square root of tau omega square plus 1, and the angle of g j omega is equals to minus tan inverse omega tau. This is the angle of the system. Third step, find out the value at omega equals to 0. So the magnitude of the system at omega equals to 0, g j omega is equals to any substitute value of 0, it will give you the value 1. At omega equals to infinity, magnitude will be g j omega is equals to 0. Similarly, the angle omega equals to 0, the angle of g j omega is equals to, at omega equals to 0, it has a 0 degree angle, and omega equals to infinite, angle will be, this is omega equals to infinite, the angle will be g j omega is equals to minus 90 degree. So this we have. So let me sketch a polar plot for this information. This is the real part, this is the imaginary part. So what we have, at omega equals to 0, the magnitude is equals to 1. So we will mark the 1 position, let's say this is your plus 1. And omega equals to infinite, we have 0 magnitude. So we have 0 magnitude. This is the 0 magnitude. Okay. So angle is starting from 0 position and up from the minus 90 degree. So starting from this position and end up with at this position at the angle of minus 90 degree. So starting at 0 degree angle, this is a 0 degree angle, and end up with a minus 90 degree. So we also identify if there is any position when real and imaginary part. So let's convert this g j omega into the real and imaginary point. So we have 1 upon j tau omega plus 1 multiplied by 1 minus j tau omega divided by 1 minus j tau omega equals to 1 minus j omega tau divided by 1 plus omega tau whole square. Okay, so solving this equation for the different value of real and imaginary part, we will have a real value will be 1 plus omega tau whole square minus imaginary part will be omega tau 1 plus omega tau whole square. If we solve this equation by substituting real value, which is 1 plus omega tau whole square equals to 0, it will approximately give me 1 plus omega tau whole square equals to infinity, and omega something equals to infinite. Similarly, if you substitute the value in the imaginary part equals to 0, then we will have omega tau equals to 0 and omega equals to 0. So with this information we can see that these omega equals to 0 and omega equals to infinite, we have already calculated the magnitude at this position, which was omega equals to 0 we have 1 magnitude and infinite equals to we have 0 magnitude. So rather than these 2 points, there is no point exist on the real and imaginary part. So we can draw the polar plot with this information, which starts from angle 0 degree from here, and it will go to the 90 degree at this position. So direction will be like this. This is your omega equals to when we have omega equals to 0, and this will we have omega equals to infinite. Okay, similarly, if I have to mark the angle on these axes, we can mark this angle like this is your 0, minus 90, minus 180 and minus 270. So this is your minus 90 degree axis. So we have the point at minus 90 degree and we have a 0 degree point over here. Okay, so similarly let me take another example, another generalized example, that is gs equals to 1 upon tau 1s plus 1. This is a second order system, type 0, tau 2s plus 1. So we have to plot a polar plot for this. If I have to plot a polar plot for this, let me go a step by step. So the step 1 will say that I have to represent it with the j omega point. So we will have j omega equals to 1 upon j omega tau 1 plus 1 and j omega tau 2 plus 1. And second point will say that I have to represent the magnitude and the phase of the system. So magnitude of the system will be g omega equals to 1 upon square root of omega tau 1 whole square plus 1 square root of omega tau 2 whole square plus 1, and the phase of the system will be angle of g omega equals to minus tan inverse omega tau 1 and minus tan inverse omega tau 2. Okay, so next step, the third step will be we have to find out what are the value of magnitude and the phase of the system at omega equals to 0 and omega equals to infinite. So omega equals to 0, magnitude of the system g omega will be equals to 1, and at omega equals to infinite, magnitude of g omega will be equals to 0. Similarly, the phase of g omega at omega equals to 0, we have 0 degree, and at omega equals to infinite, phase of the system equals to 90 plus 90. So we will have minus 180 degree. Okay. With this information, if I have to plot a polar plot for this system, we mark an real axis and imaginary axis, and marking the angle 0 minus 90, minus 180, and minus 270 degree. So what it says, at omega equals to 0, we have magnitude equals to 1. So let me mark at omega equals to 0, we have magnitude equals to 1. This is your omega equals to 0, and magnitude is equals to mod of g omega is equals to 1. And similarly, at omega equals to infinite, we have this 0 point magnitude and have angle of minus 180 degrees. So in this direction, since the angle is minus 180 degree, it starts from somewhere in this direction, or it may also go from in this direction. So we have to find out at which point it crosses on the imaginary axis. Okay, so finding out, we will move to the next step, which is the fourth step. In the fourth step, we have to substitute the value of g omega. We have to represent this equation g omega in terms of a plus jb form. So let me first write the value of g omega, which is equals to 1 divided by j omega tau 1 plus 1 and j omega tau 2 plus 1. So if I have to represent this into a plus jb form, so I have to multiply it with the conjugate, and we have this equation. This is your real part. Similarly, we have imaginary part, which is equals to minus j. So if I have to find out the value on the imaginary and the real axis, I have to substitute the real value of g omega equals to 0. It will give you the point on the imaginary axis. Similarly, I have to put the imaginary part of this transfer function equals to 0. So it will give me the point on the axis of real axis. So when we substitute the omega equals to 0, we will have only this equation. So this will go and cancel out after the 0. So 1 minus omega square tau 1 tau 2 equals to 0, which will give us omega equals to 1 upon square root of tau 1 and tau 2. And the magnitude of the system at this point, so we will have mod of g omega. Substitute the value of omega into this equation, magnitude equation. So we will have magnitude equals to square root of tau 1 tau 2 divided by tau 1 plus tau 2. Okay, so with this information, and similarly if you substitute the value of imaginary part equals to 0, we will have this equation which will give omega equals to 0 only. So with this information we can plot. So since we have magnitude, since we have the magnitude is this magnitude and also the imaginary part is negative, so we can say that this particular point is exists on the negative part since here, and this magnitude, this value is equals to square root of tau 1 tau 2 divided by tau 1 plus tau 2, and the polar plot will go like this. It will cross at this point and will come back at minus 180 degree towards this 0. Okay, and the frequency of at this position will be equals to 1 upon square root of tau 1 tau 2. So this is what we have studied. Two type of system. One is the type 1, type 2, type 3 with have only poles at origin, and also a second order system. So in the next class we will do some numerical and we'll understand how this polar plot will help us to find out the stability of the system. Okay, thank you very much. See you in the next class.